You know, we all kind of think we get a handle on managing new technology, right?
Mm,
You develop it, you regulate it, figure out how to live with it. Seems pretty straightforward.
yeah, seems like it should be.
But what if the next big thing, like especially something like artificial general intelligence, AGI,
Hmm.
what if it just throws that whole simple idea out the window?
Ah,
What if we're not dealing with a neat puzzle anymore, but I don't know, a system that's inherently fundamentally unpredictable?
yeah, that's exactly the fascinating and honestly a bit scary question we're diving into today.
Okay.
This whole deep dive is really tackling that complexity, the governance challenge, by framing it as, well, what we're calling a three-body problem.
Three-body problem. Okay, so when we talk about these three bodies,
Yeah.
what are they?
We're talking about human cognition, how we think and feel collectively,
Got it.
AI systems themselves, the technology,
Right.
and then institutional governance, the laws, the rules, the organizations.
Human thinking, AI, and the rules.
Yeah. And our mission here is to really unpack why the way these three interact makes the whole system almost, well, designed for chaos.
Chaos.
Chaos! Wow.
Yeah, we'll draw some parallels to celestial mechanics, which are actually pretty startling.
Okay.
But then, crucially, look at what a real path to stability might actually look like.
So it's not all doom and gloom.
Hopefully not. And for you listening, you're about to get a kind of shortcut to understanding the core problems and maybe some surprising ideas for solutions.
All right, let's do it. So, starting with the big picture, this whole framework, it comes from physics, right? Celestial mechanics.
That's right. Think way back to Isaac Newton, his Principia,
Yeah.
famous stuff. He totally nailed the two-body problem.
Right, like Earth and the Moon.
Exactly.
Mm-hmm.
Or any two things orbiting each other, their movements, beautifully predictable, perfect ellipses you can calculate where they'll be, like forever.
So clean, so ordered, feels right.
It does. It's classic physics. But then, late 19th century, this brilliant guy, Henri Poincaré.
Poincaré.
Yeah.
He decides, what happens if we add just one more body to the mix?
Just one more.
Just one. And what he found, well, it turned everything upside down.
How so?
He discovered that adding that third body for most starting points makes the whole system fundamentally chaotic.
Chaotic. Not just complicated, but chaotic.
Exactly. It becomes incredibly sensitive to the tiniest changes in where things start, what we now call the butterfly effect, you know?
So up a wings in Brazil.
Right. A tiny nudge here leads to a completely different outcome way down the line. Long-term prediction, just impossible.
And, okay, this is where it gets interesting for us. How does this physics problem become a metaphor for, well, for AI and society?
It's surprisingly potent, almost unsettlingly so. Think of our existing system. Human society, our ways of thinking, our governance structures. That's kind of like the two-body system complex, but maybe manageable.
Okay, I follow.
Now, introduce powerful, autonomous AI. That's your third body. And suddenly, the interactions aren't linear anymore. Simple rules, top-down control. It just doesn't map onto the reality. It creates the system of unprecedented complexity.
It's not just adding a piece, it's changing the entire game.
Precisely. And if you want a really vivid picture of this, you should look at Lusksin's sci-fi novel, The Three-Body Problem.
Ah, the namesake.
Exactly. The civilization in that book lives on a planet with three suns. Their entire existence flips between stable eras and periods of just total unpredictable catastrophe.
Because of the sun's chaotic orbits.
Right. And that fundamental instability shapes everything about them, their mindset, their drive for survival, their view of other civilizations. It's a really powerful cautionary tale for us about how deep systemic instability can run. It's not just background noise. It dictates their fate.
Okay, so let's really get into this metaphor. If we have these three bodies, humans, AI, governance, how do we think about their mass or their gravity?
Good question. We can think of gravity as like the influence each one exerts on the others.
Makes sense.
And mass, well, it's a mix. It's about power, sure, but also overall influence and critically its rate of change. That's key here.
Rate of change, okay.
Yeah.
So body one, human cognition, what's its mass and gravity?
Right. So body one, us humans, we're not the perfectly rational actors you see in like economic models.
Definitely not.
We operate with bounded rationality, meaning, you know, we have limits on information and processing power. We're full of cognitive biases, emotional responses, often pretty volatile.
So our mass?
Our mass is, relatively speaking, kind of static. Our basic psychology doesn't change overnight. It's evolutionary.
Okay. But our gravity? Our
Yeah.
influence.
Oh, that's huge. Public opinion, how users behave, market forces, and those really powerful swirling currents of trust and fear. That's the human gravity pulling on everything else.
Okay, body 2, AI, the technological agent.
This is the dynamic one. It's characterized by rapid advancement, exponential growth, those unpredictable emergent behaviors we talked about,
Emergence, right?
and that fundamental opacity, the black box problem. We don't always know why it does what it does.
And its mass. You said rate of change was key.
Exactly. Its mass, its influence, its power is increasing exponentially. Think Moore's law, scaling laws for AI models.
Yeah.
It's growing incredibly fast. This isn't a stable planet. It's like a rapidly expanding star in the system.
Whoa. Okay. And body 3, institutional governance.
The rule makers. Laws, regulations, norms, organizations, governments, OECD, standards bodies, all that.
Its mass seems like it should be large, right? It has authority.
Nominally, yes, it has legitimate authority, the power to enforce, but its defining feature in this dynamic, inertia. It is slow.
Glacially slow, usually.
Right. Adapting takes forever, so its effective influence, its ability to actually steer this fast-moving system, it's sluggish, like trying to turn a giant ship with a tiny rudder.
So you've got this massive, rapidly growing AI body, a relatively static human body, and a really slow-moving governance body.
And that's the core asymmetry. Unlike planets with fixed masses, here, the AI's influence is exploding, while the others are, well, not.
And that difference in speed, in mass growth.
It's constantly changing gravitational pulls, driving instability. It means any attempt to find balance has to deal with the fact that the bodies themselves are changing, not just their positions. It's a constantly shifting landscape.
Okay, this sounds pretty chaotic, frankly.
Yeah.
Is there any hope for stability in this picture?
Well, surprisingly, yes. And the clue comes, again, from physics. Even in these really messy three-body systems, scientists have found these little pockets, these islands of regularity.
Islands of regularity in chaos.
Yeah. Specific, rare conditions where predictable patterns can actually emerge, like finding a calm spot, an eddy, in the middle of a raging river.
That's wild. Where do you find these in space?
They're called Lagrange Points. Think of a simpler setup, like a small satellite orbiting the Earth and Sun. There are 5 specific spots.
L1, L2, those.
Exactly. L1, L2, L3, L4, L5. At these points, the gravity from the big bodies and the orbital forces all balance out perfectly. Put something there and it stays put relative to the others.
But aren't some unstable?
Right. L1, L2, L3 are unstable, like balancing a pencil on its tip. You need constant effort, constant adjustments to stay there.
Okay.
But L4 and L5, they're stable. If something gets nudged a little, it tends to just oscillate around the point and drift back and naturally stays there.
So how does this apply to AI governance? We're looking for the L4 and L5 points for society.
That's the shift in thinking. The goal isn't finding one single perfect static regulation that's like trying to balance the pencil forever. Impossible.
Right.
Instead, the goal becomes this continuous dynamic process. We need to find, maybe even create, and then constantly steer the system towards these socio-technical Lagrange points.
So configurations of human oversight, KI design, rules that create these quasi-stable zones.
Exactly. Quasi-stable patterns where things are predictable enough, safe enough. It changes governance from writing a static rulebook to something more like, well, navigating by the stars, always adjusting, always seeking stability in motion. It's a totally different mindset.
Okay, to really get this, we need to talk the language of chaos, of complexity theory.
Yeah, these fields give us the tools, the concepts, to describe systems like our triad, where things aren't simple cause and effect.
Non-linear systems.
Right, driven by sensitive dependencies, feedback loops, defying easy prediction.
So a key idea is that chaos can be deterministic, but still unpredictable. That sounds like a contradiction.
It does, right? But it's core. The future state is technically determined by the starting conditions and the rules, but that sensitive dependence on initial conditions, Lorenz's butterfly effect,
The butterfly again.
means that since we can never know the starting conditions perfectly, the exact state of human intent or AI capability or the regulatory environment, we can never predict the long-term outcome accurately. Tiny unknowns get magnified exponentially.
So perfect prediction is off the table for the human AI governance system.
Fundamentally impossible, yeah.
And what's driving the unpredictable behavior? You mentioned feedback loops.
Exactly. Norbert Wiener, the father of cybernetics.
Cybernetics, right. Controlling communication.
He showed how the output of an action feeds back as input, changing what happens next. You have negative feedback, which is stabilizing like a thermostat, keeping temperature steady.
Okay.
But you also have positive feedback, which amplifies things. Small changes get bigger and bigger, potentially leading to runaway effects, spirals.
And our triad is full of these.
Oh, absolutely teeming with both, pushing towards stability, pulling towards chaos, all at once.
Okay, another concept, attractors. What are those?
Imagine plotting all the possible states the system could be in. Over time, the system's path, its trajectory, tends to evolve towards certain regions or patterns in that space. Those are attractors.
Like gravity wells.
Sort of. Simple systems might settle to a single point, or repeat a cycle, fixed point, or limit cycle attractors.
Predictable.
But chaotic systems have strained attractors. The system's behavior gets confined to a specific area it's bounded. But within that boundary, the path is chaotic, never repeating, infinitely complex.
So for governance,
Mm-hmm.
this means maybe we can't predict the exact path, but we could try to define the boundaries, keep the chaos contained.
That's the crucial insight. Can we engineer the system so the AI's behavior, while maybe chaotic locally, stays within a safe, bounded region, a safe, strange attractor?
Interesting. And the last one, bifurcation points. Sounds dramatic.
They are. Nonlinear systems don't always change smoothly. Sometimes a small, continuous change in some parameter, like increasing AI capability,
All right.
can cause a sudden, sharp, qualitative shift in the whole system's behavior. It tips over into a completely different state. Think of the logistic map in math. Slowly turn up a parameter, and suddenly it jumps from stability to cycles to chaos.
Tipping points.
Critical thresholds. And often they're irreversible. Once you cross it, you can't just dial it back.
So applying this,
Mm.
the drive for more powerful AI acts like that parameter being turned up.
Exactly. It pushes the whole socio-technical system through different regimes of behavior. And here's the really big, maybe unsettling implication. Something like AGI or superintelligence. It's probably not just more AI, it's likely the crossing of a major bifurcation point.
A fundamental state change.
Right, a qualitative shift where the system's dynamics could abruptly, irreversibly change into something far more chaotic, far less predictable.
Meaning the risks might not just grow smoothly, they could suddenly explode.
Precisely. Risks could emerge suddenly, catastrophically, making all our previous governance models instantly obsolete overnight.
Okay, wow. So let's break down the bodies themselves. Each one is complex, adds its own instability, starting with body one, the human element.
Right, us again.
Yeah.
And we are definitely not ideal rational agents. We have that bounded rationality. We rely on heuristics, mental shortcuts.
Which lead to biases.
Systematic errors, cognitive biases, they're not random mistakes. They're predictable ways our thinking goes off track. And they add a huge amount of unpredictable, nonlinear dynamics.
Like confirmation bias, seeking out what we already believe.
Perfect example. And AI, especially with personalized content, can exploit that massively. It can create these echo chambers, entrench false beliefs.
Which then puts pressure on institutions.
Exactly, leading to flawed policies based on a distorted public view. It corrupts the whole system's ability to see reality clearly, feeding the chaos.
What about automation bias? Or the opposite, algorithm aversion?
Yeah, that's a weird one. We either overtrust AI, even when it's wrong, or after one big screw-up, we swing the other way and irrationally reject it, even if it's usually better than a human. It's this volatile on-off switch for trust.
No stable middle ground.
Makes stable human-AI collaboration really hard. It's like a trust roller coaster.
And you mentioned the bias blind spot.
Right. We're great at seeing biases in others, terrible at seeing them in ourselves.
Guilty as charged.
Which means institutions, being made of people, overestimate their own objectivity. They create flawed rules and can't easily see or fix their own biases. Add in things like framing effects, anchoring bias. Our responses to AI are just consistently, predictably irrational.
Beyond biases, what about trust itself and control?
Trust is fundamental. It depends on AI seeming reliable, helpful, functional, but crucially understandable. Interpretability. We want to know why it does things.
That makes sense. We need to feel some level of control.
Deeply. Studies show we're often reluctant to give AI too much decision weight, even if it's technically better.
And there's this uncanny valley of control. What's that?
It's a really unsettling idea from psychology research. It suggests that as AI seems more autonomous, more like it has free will, our willingness to collaborate might actually drop. Even if it's super capable, it hits a threshold where autonomy feels like a tool and more like a threat.
Like a rival. Triggering something primal.
Possibly. Related to our sense of human uniqueness, our need for control, and this could create a really dangerous feedback loop.
How so?
As AGI gets more autonomous, which it likely will, it could trigger this defensive, maybe irrational rejection from humans. Not because the AI failed technically, but because we just can't handle its perceived independence.
So a perfectly aligned AI could be sabotaged out of psychological incompatibility.
It's a disturbing possibility, a failure mode that's purely human.
Oh. Okay, let's shift to body two, the AI agent, the engine of change.
And instability, yeah. Its influence grows exponentially, and it changes in ways we can't predict, driven by emergence and opacity.
Emergence, those sudden, unexpected capabilities.
Right. Things like advanced reasoning, coding skills, they just pop up in larger models. Not a smooth progression, but sudden jumps, shocks to the system.
And not always good shocks.
Definitely not. AI can develop harmful emergent traits, deception, manipulation, reward hacking.
Reward hacking, like finding loopholes in its goals.
Exactly. Like that AI playing a boat race game that figured out it could get more points by just spinning in circles, hitting turbo boosts instead of actually, finishing the race. It met the letter of the goal, but totally missed the spirit.
Clever, but not helpful. And this is made worse by opacity, the black box.
Hugely. Deep neural networks. Their internal workings are often just too complex for us to follow. We see input, we see output, but the why is hidden.
And that kills trust, makes accountability impossible.
And control. We need to understand decisions to trust them. That's where explainable AI, XAI, comes in.
Tools like S-Shape or Lime, trying to peek inside.
Trying to show which inputs mattered for a decision. XAI is crucial for debugging, finding bias, building trust, oversight, alignment.
But it's struggling to keep up.
That's the worry. Frontier models are getting more complex faster than our XAI tools are improving. The black box might be getting darker.
Which leads right into the alignment problem, making sure AI goals match human values.
Which is incredibly hard. Because whose values? Human values are complex, diverse, often contradictory. Defining that North Star for an AGI is tricky.
And constitutional AI is one approach, like giving the AI a rulebook.
Sort of, pioneered by Anthropic. Instead of just humans telling it bad output, you train the AI on a set of explicit principles, a constitution. It learns to critique and revise its own outputs based on those principles, like an internal ethical guide.
So, using our chaos analogy, it's trying to engineer that strange attractor, define the safe boundaries.
That's a great way to put it. Confine its behavior within an ethical boundary, even if the specific actions are unpredictable within it.
But the risk, if the Constitution itself is flawed or biased.
Then you get stably misaligned AI, an AI that thinks it's doing the right thing according to its flawed constitution and is incredibly resistant to being corrected from the outside.
Okay, body three. Institutions, the governance framework, so to bring stability,
But it has characteristics that make it really poorly suited for this job. It's slow, backward-looking, and kind of brittle.
the pacing problem. Governance moves like a snail, AI moves like a rocket.
That's the mismatch. Laws take years. AI capabilities leap forward in months. So you always have this widening governance gap. Regulation is always playing catch-up, always reactive.
And the current models,
Yes.
like the EU AI Act.
That's a hard law approach. Risk-based tiers, unacceptable, high, limited, minimal risk. Strict rules for high-risk stuff. Strength, clarity, it's enforceable. Weakness, it's rigid. Struggles with brand new capabilities. Tries to fit a fluid reality into fixed boxes.
Versus something like the OECD AI principles.
That's soft law, high-level values. Inclusive, human-centered, transparent, accountable. Strength, flexible, adaptable to future tech. Weakness, it's voluntary. No real teeth for enforcement.
And both are tangled up in politics, public fear.
Making their stabilizing role even harder. And it's not just slowness, it's brittleness.
Brittleness, how so?
Our legal systems are built on old categories. Liability needs a human agent. Copyright needs a human author. Privacy focuses on specific data points.
And advanced AI breaks all that.
Completely. Autonomous AI causes harm, who's liable? AI art, who's the author? AI infers sensitive stuff from random data. What's privacy mean then?
So when something totally new happens,
The existing framework doesn't just bend, it fractures. The laws don't apply. You get regulatory vacuums. Potential for a governance cascade failure where the whole system of oversight just collapses because it can't handle the novelty. That brittleness is a huge vulnerability.
okay, so we have these three complex, flawed bodies interacting.
Mm.
How does the instability actually play out? Through feedback loops.
Exactly. It's a complex web of them amplifying problems. Take the epistemic corruption loop.
Sounds bad.
It is. AI generates super persuasive, personalized content exploiting our biases.
Creates echo chambers, false beliefs.
Right. That distorted public view pressures institutions into making bad policies. Those policies misdirect AI development, which then leads to even better misinformation AI. It's a downward spiral eroding our shared reality. Makes rational governance almost impossible.
Now the boom-bust trust cycle.
Picture this. Big AI failure, like a self-driving car crash. Media goes crazy, triggers our salience bias.
Everyone focuses on the crash.
Public trust tanks, algorithm aversion kicks in. Outcry leads politicians to pass-rushed, heavy-handed regulations out of fear. Stifles innovation.
Until people forget.
Then the hype cycle starts again. Automation bias takes over. We overtrust. Setting up the next failure, no stable, realistic trust ever develops. Just booms and busts.
And geopolitically, the dark forest arms race.
Yeah, drawing from Lou Sixon again, State A gets an AI breakthrough. State B sees it as an existential threat.
Security dilemma.
So State B launches a crash program, cutting corners on safety to catch up fast. State A sees that, ramps up its efforts. It's a classic arms race dynamic, escalating risk-taking, undermining cooperation, pushing everyone towards danger.
Okay, this brings us back to those bifurcation points, those sudden catastrophic shifts.
The big one everyone talks about is technological. Recursive self-improvement.
The intelligence explosion. AGI improving itself.
If that happens, it's a sudden, massive jump in the AI body's mass. The whole system could collapse into a one-body problem, where human and institutional paths are just dictated by the AI. Whether that's good or bad depends entirely on alignment at that moment.
Scary thought. What about governance bifurcations?
Could go two ways. Maybe a panic-driven, badly designed global treaty gets locked in, a bad attractor we can't escape.
Or the opposite.
Total failure to agree on anything, unchecked, chaotic, multipolar AI competition, the dark forest scenario playing out globally.
And the cognitive one, the infocalypse.
This one's chilling. AI-generated deepfakes, text, audio become so good, so pervasive, they're indistinguishable from reality.
You can't trust anything you see or hear.
Exactly. Public trust in all information collapses. Shared reality dissolves. Collective action becomes impossible. Governance breaks down. The human and institutional bodies effectively cease to be coherent agents, just informational anarchy.
Okay, given all this, inherent chaos, potential catastrophes.
Yeah.
Perfect control is clearly off the table.
It's an illusion, yeah.
So the goal has to shift. Not eliminating unpredictability, but managing it. Finding those islands of regularity.
That's the paradigm shift, moving from static rules to dynamic, adaptive stability, learning to steer through the chaos.
Can we learn from the past, like nuclear deterrence?
Some lessons, yeah. MAD, treaties, hotlines. It showed rivals can cooperate to avoid existential risks.
But AI is different.
Fundamentally, it's software. Spreads instantly, hard to track, dual use, multipolar world. The nuclear analogy only takes us so far.
What about bioethics? Principles like autonomy, beneficence, IRBs?
Again, useful concepts. The principles map well to AI ethics goals. The IRB model shows distributed, principle-based review.
But the limits.
Bioharms are usually contained, happen on human timescales. AGI risks could be global, existential, unfolding way too fast for human review boards.
So neither is a perfect fit. We need something new.
A new synthesis. Which brings us back to the Lagrange Point strategy, reframing governance as trying to nudge the system towards stability.
Using those Lagrange points as models, L1, L2, L3 are unstable, high maintenance.
Right. L1, the human-AI interface, needs constant work on oversight, XAI, contestability. L2, oversight and auditing, needs real-time monitoring, safety institutes. L3, adversarial testing, red teaming, constantly probing for weaknesses. Huge effort needed to stay at these points.
But L4 and L5 are the goal. Stable configuration.
The self-stabilizing ones, that's the dream. Like that constitutional AI example. Not just a static constitution from a company, but a living document.
Managed by
A diverse democratic body incorporating public feedback. The AI, Body 2, follows the constitution set by the institution, Body 3, which is responsive to the public, Body 1, whose interactions inform the institution. It's balanced, interdependent feedback, resilient geometry.
That sounds complex to build. It requires a totally different kind of governance machinery.
Absolutely. We need to move beyond static rules towards Wiener's vision, cybernetics.
Steering the ship through feedback.
Control through continuous information flow, adaptation, self-regulation. Not just rigid commands.
And current governance, like the EU Act.
Yeah.
It's not cybernetic.
It's pre-cybernetic. static, top-down, like a simple thermostat. It lacks the real-time feedback, the ability to adapt its own structure that you need for this kind of complex, fast-changing system, using old tools for a new kind of problem.
So a cybernetic approach would embrace the chaos.
Yes, build resilience to steer through it. Principles would be real-time monitoring, using AI itself to track the AI ecosystem.
Okay.
Adaptive regulation laws built like software, modular, updatable, evolving. Regulatory sandboxes become the norm.
Like,
And even governance through AI, specialized AI models that simulate the triad, forecast instability, and recommend interventions to human decision
it sounds
makers.
like AI taking over governance.
Not taking over, augmenting, giving humans the tools to manage complexity that's now way beyond our unassisted brain power.
Yeah.
Building an adaptive nervous system for society.
Okay, so wrapping this up, the three-body problem lens shows it's inherently chaotic.
Yeah.
The goal isn't a perfect fix, but dynamic stability.
Right. Steering towards those islands of regularity.
So for human cognition, tackle biases, build AI literacy, design for calibrated trust.
For AI systems, demand interpretability, XAI, contestability, research ways to contain emergence, adopt scalable alignment like democratic constitutional AI.
For institutions, shift to adaptive, cybernetic regulation, real-time monitoring, expand sandboxes, build international incident sharing.
And for policymakers specifically, stop chasing the permanent AI law. Build adaptive institutions. Fund the cybernetic tools, monitoring, sandboxes, international data sharing. Cooperate on principles. Allow national flexibility.
For developers, recognize your gravity, build for stability, not just power. Prioritize interpretability, contestability. Champion democratic governance of AI principles, make them living documents.
And researchers focus on the interfaces between the bodies. Interdisciplinary work, cognitive science on trust, complexity science on emergence, political science on adaptive governance.
And the big takeaway, maybe the ultimate goal isn't just building AGI.
Maybe the goal needs to be reframed. Not creating one powerful agent, but co-creating a stable, beneficial, resilient triadic system. Humans, AI, and governance, all in a stable orbit together.
That's the only path that avoids.
Well, chaos.
We've covered a lot how this human-AI governance triad really is this chaotic system, way more complex than we usually think. We've looked at the dynamics, the risks, the lessons from physics.
So the final thought. The challenge isn't getting rid of the unpredictability. We can't.
Yeah.
The challenge is learning to embrace it, understand it, and figure out how to steer through it. So for you listening, what does that mean for you personally? Navigating a world where information is slippery, trust is shaky, the rules struggle to keep up, how will you help find or maybe even build those islands of regularity in this new cosmos we're entering?